All right, get ready, because today we are going deep, deep into a true cosmic mystery.
Ooh, I like the sound of that.
We're talking the hunt for Planet 9.
Planet 9, yeah.
You guys have been sending in a ton of questions about this ever since that article came out, the one summarizing the discussion with,
With Konstantin Batygin.
right, Professor Batygin,
Yeah, he's in there.
who, if you don't know, he's a planetary scientist who has been making a lot of noise, you could say, about this potential ninth planet just hiding out in our solar system.
Yeah, he's been making some pretty compelling arguments, I gotta say.
Yeah, and the thing that I think is so cool about this, unlike some of the more, fringe theories we cover, this isn't just like science fiction,
Right.
right? There's some actual evidence to back this up.
Yeah, and that's what's got everyone so excited, We could be talking about something as big as Pluto, maybe even bigger.
Pluto on steroids?
Exactly, and we're talking about using AI, these super-powered simulations. Really, it's a cosmic detective story.
Yeah, well, let's dive in and break down some of these clues, right?
Absolutely.
I mean, the big thing that I keep hearing about is the Kuiper Belt, right? This region that's way out beyond Neptune. It's full of all these icy objects.
Icy objects, yeah.
And I gotta say, on the surface, it just sounds kind of like, boring, just a bunch of icy rocks. So what's the big deal?
Yeah, at first glance, it might not seem all that exciting. It's like, oh, just a bunch of leftover debris from the formation of the solar system, right?
Exactly.
But when astronomers started studying the orbits of these objects more closely, they noticed something really peculiar.
What's that?
These objects, they're not just randomly scattered out there.
Right.
They're actually clustered together
Clustered together. Okay.
in a way that's incredibly unlikely to happen by pure chance.
Okay, so give me an example. Like, how unlikely are we talking? Because, sometimes things clump together, right?
Sure, it's kind of like imagine you're walking through a field and you find a four-leaf clover. That's lucky, but it happens, right?
Yeah.
But then you take another step and you find another four-leaf clover and another and another.
Wow.
At some point, you start to think, wait a minute, something strange is going on here.
Right. There's got to be something else.
Exactly. And in the case of the Kuiper Belt, statistically speaking, we're talking 5 sigma.
5 sigma. Okay.
That means there's only about a 1 in 3.5 million chance that this clustering is just random.
Wow.
It's a really strong signal.
Yeah, that's wild.
And so scientists are convinced there must be something else at play, some unseen force that's shepherding these objects into these peculiar orbits.
So that force is, as a lot of people believe, Planet 9.
Potentially, yeah.
This hypothetical planet that we haven't actually seen yet, but we're seeing basically its fingerprints.
It's gravitational influence.
Right.
Yeah, it's almost like we're trying to find a ghost.
Mm-hmm.
We can't see it directly, but we can see its effects on the things around it.
So how do you even begin to hunt for a planet that you can't see, right?
Yeah.
I mean, that's the big question. You can't just, point a telescope up and hope you get lucky.
Right. It's definitely not that simple. But thankfully, we have these incredible tools at our disposal now. And one of them is called N-body simulations.
N-body simulation.
And
right.
basically, imagine you have the supercomputer that's playing a cosmic game of billiards.
Oh, wow.
But instead of balls, it's using planets.
Oh, like that.
Right. So by adding a hypothetical planet 9 into this simulation, we can actually see how its gravity would affect the rest of the solar system over billions of years.
So it's like a cosmic rewind button, right? You're saying, okay, we have this solar system, we have these orbits that we see today. Let's rewind it. Let's see if Planet 9 could explain how we got here.
Exactly.
That's so cool.
And to make things even more interesting, we're incorporating AI and machine learning into these simulations now.
Oh, wow. So AI is hunting for planets.
Yeah, AI is playing a crucial role in refining these models, sifting through mountains of data.
It's a sci-fi movie.
It really is.
But, I got to ask, at the end of the day, aren't simulations just that? Simulations, right? I mean, how do we know that what we're seeing in these computer models is actually reflecting reality?
Yeah, that's an excellent point.
It's a really good point.
Because simulations are only as good as the data that we feed them.
Right.
There's always a chance of, errors, biases, or even just missing information.
Yeah.
So that's why it's crucial to constantly compare these simulation results to what we actually observe out there in the solar system.
Right, that ground truth, you got to have it.
Yeah, because if they don't match up, it could mean that we need to tweak the model.
Right.
Or maybe even rethink some of our assumptions.
Makes you think about Pluto, right?
Oh, yeah, definitely.
Because, remember when Pluto got demoted to a dwarf planet?
Poor Pluto.
Poor Pluto. It's like the The biggest planetary news in our lifetime, probably. And it really just shows that what we think we know about the solar system, even something as seemingly basic as, what is a planet, can change.
It's always evolving, right?
Exactly.
And Pluto's story, it's a perfect example of that. When it was first discovered back in 1930, astronomers thought they'd finally found this mysterious planet X, a hypothetical planet that they believed was out there tugging on the orbits of Uranus and Neptune.
Hmm.
But as we learned more about Pluto,
Hmm.
Especially after we discovered its moon, Charon, it became clear that Pluto was much smaller than we initially thought.
It wasn't this, massive world.
Exactly. It wasn't the planet they were looking for.
It wasn't the planet X.
No,
And eventually, it got kicked out of the planet club.
sadly.
Poor Pluto. But I guess it goes to show, like you said, science always evolving, right?
All
And
of it.
what we think we know can change in an instant.
Ab-
So if this Planet 9, if it does exist, I guess the first question is, how did it end up way out there in the first place?
Right.
I mean, isn't it awfully crowded for another planet to be hanging out in those outer regions of the solar system?
Yeah, I mean, the outer regions of the solar system, they're not exactly packed with planets. But you're right, there are definitely some limitations to how much planetary real estate is actually available out there.
Interesting.
The further you go from the sun, the weaker its gravitational pull becomes.
Right.
And all these other factors start to come into play.
Oh, interesting. Okay, so what do you mean? So a planet would have to be pretty massive, I imagine, to hold its own way out there in the outskirts.
Exactly. It would need a significant amount of gravity to resist these other forces.
So what kind of other factors are we talking about? Paint a picture for me. What else is going on out there in the deep, dark depths of the solar system?
Well, for starters, there's something called the galactic tide.
The galactic tide. Oh, I haven't heard of that.
Yeah, and it's this very subtle but persistent gravitational pull from the Milky Way itself.
Oh, wow. So the whole galaxy is tugging on it.
Exactly. It's a very gentle tug, but over vast timescales, it can really disrupt orbits.
Wow.
And then you've got to consider the possibility of passing stars.
Mm.
Every once in a while, a rogue star might wander a little too close to our solar system.
Oh, that sounds scary.
And if that happens, it could create enough gravitational chaos to actually fling a planet right out of the solar system.
Like a cosmic eviction notice.
Exactly.
Oh, that's wild.
And then, of course, we can't forget about the Oort cloud.
Oh, right. The Oort cloud.
Which is this giant sphere of icy bodies that surrounds the entire solar system.
Way, way out there.
Way out there, even beyond Pluto and the Kuiper Belt.
Yeah.
And if there are any planets hanging out in that region, they would be constantly interacting with these icy objects, which could lead to some pretty chaotic and unpredictable orbital dynamics.
Wow, so it's like a cosmic obstacle course out there.
It really is.
So given all of these challenges, how on Earth are we going to actually find this elusive Planet 9?
Well, one of the things that has a lot of people excited is this new observatory that's being built down in Chile, the Vera Rubin Observatory.
Oh, yeah, I've heard of that.
Yeah, and it's going to house something called the LST.
The LSST, that's the Legacy Survey of Space and Time?
You got it.
Right, it's like trading in a magnifying glass for a high-powered telescope, from what I've read.
Absolutely.
It's going to be able to scan huge chunks of the sky, right?
Yeah, vast swaths of the sky every single night.
Oh, wow.
And it can detect objects that are way fainter than what we can see with current telescopes.
And that's critical because Planet 9 is going to be pretty dim, right?
Yeah, exactly. It's likely to be very faint and very far away.
So it's a needle in a haystack.
It really is.
But they're building a bigger haystack, or I guess a better needle finder.
Exactly. The LSST is going to dramatically increase our chances of actually spotting something like Planet 9.
Okay, so the LSST, it's going to give us a ton of data.
Mountains of it.
But how do we sift through all that information? I mean, that's got to be an overwhelming amount of data.
Right, but that's where the power of AI comes in again.
AI to the rescue.
Because these algorithms can analyze vast amounts of data.
Right.
Way more efficiently than any human ever could.
Oh, interesting.
And they can identify these subtle patterns and anomalies in the data that might indicate the presence of this distant world. Even one that's as faint and elusive as Planet 9.
So it's like having a team of superpowered cosmic detectives working around the clock.
Exactly.
Yeah.
They're analyzing every single pixel of the sky, looking for any hint of something out of the ordinary.
And the cool thing about AI is that it's always getting smarter. right? The more data you feed it,
Absolutely.
the better it gets at recognizing these little tiny
The
clues.
more it learns.
It's amazing.
Yeah. So it's really exciting to think that we might actually be able to use AI to make this incredible discovery.
It really is.
To find a new planet in our own solar system.
I love it.
It's pretty incredible.
It's a truly cosmic mystery.
It is.
And we are, well, we're just getting started.
Yeah, just scratching the surface.
So let's take a quick break, and when we come back, we'll dive even deeper into this whole Planet 9 saga.
Sounds good. A monumental discovery for sure. But let's say, just for argument's sake, that Planet 9 is out there, lurking in the darkness.
Okay.
What do we actually think we know about this mysterious world? I mean, what are we talking about here?
Yeah, paint me a picture. What kind of planet are we imagining? Is it a gas giant like Jupiter or something completely different?
Well, that's one of the big mysteries we're trying to unravel, right? Based on those simulations we talked about and the gravitational effects we're seeing in the Kuiper Belt. Astronomers believe Planet 9 is likely what we call a super-Earth.
Oh, a super-Earth. Okay. That sounds pretty intriguing. What exactly does that mean?
So basically it means it's bigger and heavier than Earth,
Okay.
but smaller than Neptune. So think somewhere between 5 and 10 times the mass of our planet.
Wow. That's a pretty hefty world.
Yeah, no kidding.
But what about its composition? I mean, is it rocky, icy, gassy? What are we dealing with here?
That's still a bit of a puzzle. We don't have all the answers yet.
Right.
But given its presumed location way out there in the cold, dark depths of the outer solar system.
Yeah, it's not exactly prime real estate.
Right, it's pretty far out.
Yeah.
So it likely has a significant amount of ice in its makeup, perhaps even a thick atmosphere of volatile gases like methane and ammonia.
Oh, so not exactly a place you'd want to build a summer home.
Probably not, no. The surface temperature is estimated to be incredibly frigid.
Yeah.
Hundreds of degrees below freezing, so definitely not a place you'd want to go for vacation.
Noted. But even though it's so far away and so cold, this Planet 9, it could hold clues to some pretty big questions. Right? Like, how did our solar system even form in the first place?
Absolutely. You're thinking like a true scientist, because the existence of a planet like this, so far out, with such an unusual orbit, it would really challenge our current models of solar system formation.
In what way?
Well, for example, we'd need to figure out how a planet could even end up so far out in the boonies, in the first place.
Right, like how does a planet get kicked out that far? I mean, is there another way it could end up in those outer regions?
Yeah, there are a couple of leading theories. One possibility is that Planet 9 actually formed much closer to the sun, alongside the other gas giants like Jupiter and Saturn, but then got gravitationally scattered outward during the early solar system's history, kind of like a cosmic billiards game.
Oh, like Jupiter and Saturn were just bullying little Planet 9 and flung it out to the edge.
Exactly. Imagine these massive gravitational bullies just tossing this planet out to the edge of the solar system.
It's a cosmic eviction notice.
Yeah, that's one possibility.
Okay, I can see how that might happen.
The other possibility is that Planet 9 actually formed out there in the outer solar system, far beyond where the gas giants reside.
Oh, interesting.
And this would require a different formation scenario, perhaps involving a process called pebble accretion.
Pebble accretion, okay.
Where you have these small, icy pebbles that gradually clump together over millions of years.
Oh, wow. So they just slowly build up.
Yeah, until you eventually form a planet.
So either a planetary exile or a homegrown world in the cosmic suburbs.
It's pretty wild to think about, right?
Yeah, it really is. Either way, it's a fascinating story.
Yeah, and the discovery of Planet 9, it wouldn't just reshape our understanding of our own solar system. It could also provide insights into planetary formation processes around other stars.
Oh, interesting. Speaking of other stars, we've been hearing so much about exoplanets lately.
Exoplanets, yeah.
These planets orbiting stars beyond our sun. Are there any connections between the search for Planet 9 and all this exoplanet research that's going on?
Definitely. There are some really interesting parallels between the two.
Like what?
Well, for one thing, both fields rely heavily on indirect detection methods. We can't directly image most exoplanets.
Right.
And we haven't actually seen Planet 9 directly either.
Right. It's all about those gravitational fingerprints.
Exactly. We have to infer their existence based on their gravitational effects on other objects.
So whether we're talking about objects in the Kuiper Belt or stars in distant galaxies, it's all about looking for those subtle tugs and wobbles.
Precisely. And another connection is that both fields are really pushing the boundaries of our observational capabilities. Just like we're developing these new incredible telescopes to search for fainter and more distant exoplanets,
Right.
we're also building instruments like the LSST to probe the outer reaches of our own solar system in search of Planet 9.
It's fascinating how those two fields are so interconnected. We're expanding our cosmic horizons in both directions, outward to other star systems and inward to the hidden corners of our own solar neighborhood.
Exactly.
It's really cool. Okay, so back to Planet 9. If we do find it, I mean, what would its discovery mean for our understanding of, well, everything? Would we have to rewrite the textbooks, redesign our solar system models?
It would certainly be a major shift in our understanding, that's for sure.
Yeah.
First and foremost, we'd have to revise our whole understanding of the architecture of our solar system. Instead of ending abruptly at Neptune,
Right.
it would extend much farther out.
Along Neptune, you're not the edge of the map anymore.
Exactly, with Planet 9 marking a new outer boundary.
Wow.
But beyond the sheer awe of discovering a new world, there are some really profound scientific implications. We might have to rethink our models of solar system formation, as we discussed earlier.
Right.
And it could also give us clues about the early history of our solar system, including the possibility of these ancient planetary migrations and collisions.
Wow. So it's not just about adding a new dot to our solar system model. It's about understanding the whole story.
The whole intricate dance of planets.
Yeah. And how they got to where they are today.
Exactly.
It really underscores how much we still don't know about our own cosmic backyard.
It really does. And it would also raise some fascinating new questions, like if a planet like this could form or migrate to such a distant orbit, what else might be lurking out there in the darkness? Could there be other, even more distant planets yet to be discovered?
Multiple Planet Nines. Now that's a truly mind-boggling thought.
It really is.
This whole conversation makes you realize we're out there searching for signs of life on other planets, but we still haven't fully explored our own solar system.
It is a humbling reminder that the universe is full of surprises.
Yeah.
And even in our own little corner of the cosmos, there's still so much left to discover.
That's for sure. All right, let's get back to this whole Planet 9 thing.
You had to Planet 9.
I mean, we've talked about all these clues, the possibility of it being out there, but the big question, I think, in everybody's mind is, will we ever actually find it?
Yeah, that's the million-dollar question, isn't it? It
Yeah.
really is like searching for a needle in a cosmic haystack.
Yeah.
But, even with all the challenges, I'm actually pretty optimistic.
Optimistic, really. I gotta say, I'm a little bit more skeptical, I guess,
Okay.
because this planet, if it even exists, it's incredibly far away. It's incredibly faint. It could be literally anywhere in this vast, expansive space. What makes you think we actually have a shot at finding it?
Well, for one thing, we're not exactly going in blind, right?
Right.
Remember that Vera Rubin Observatory we talked about?
Oh, yeah, with the LSST.
With the LSST, exactly. That's going to be a game changer in this search.
That's the one down in Chile, right?
Down in Chile, yeah.
Designed to scan the entire southern sky, like every few nights, right?
It is, yeah. It's going to survey the entire southern sky multiple times.
It's, like I said before, trading in a magnifying glass for a high-powered telescope.
Exactly. And the LSST's ability to detect these faint objects and its incredibly wide field of view,
Yeah.
that's really going to increase our chances of spotting something like Planet 9.
So more data, but again, that brings me back to my point of, like, even with all that data pouring in, aren't we still talking about finding, this tiny little blip in a massive amount of information? How do we even begin to, sift through all that to pinpoint Planet 9?
And that is where the power of AI and machine learning really comes in.
AI to the rescue again.
I know, right? AI is really the hero of this story because these algorithms can analyze vast amounts of data.
Yeah.
Much more efficiently than humans ever could.
Sure.
They can identify these subtle patterns and anomalies that might indicate the presence of a distant world, even one as elusive as Planet 9.
So it's like having a team of, tireless, never sleeping, super-powered cosmic detectives.
Exactly. They're working around the clock, analyzing every pixel of the sky, looking for any little hint of something out of the ordinary.
I love it.
And the best part is, the more data we feed these algorithms, the better they get at recognizing those telltale signs of a hidden planet.
So they're constantly learning and improving.
They are. They're constantly evolving.
That's pretty amazing.
It is. It's really exciting.
Okay, so let's say, just for a moment, that we do find something, right? We're looking through all this data from the LSST, and boom, there it is, something that looks like Planet 9.
Uh-huh.
But how do we actually confirm it? How do we know for sure that it's not just some weird anomaly in the data or some, other object that's just kind of passing through?
That's a great question, and confirmation would definitely require multiple lines of evidence. It can't just be a one-off thing.
Right.
First, we would need to carefully track its movement over time.
Okay.
We'd want to see it moving against the background of stars, following a consistent orbital path.
So we got to see it actually moving, not just sitting there like a cosmic photobomb.
Exactly. We need to make sure it's a bound object within our solar system.
Okay, that makes sense.
And then, once we've confirmed its movement, we would want to gather more detailed observations.
Okay.
Perhaps using space telescopes like Hubble or James Webb.
The big guns.
Yeah, the big guns to study its physical characteristics.
Yeah.
Determine its size, its composition, its atmosphere if it has one.
Get its cosmic passport.
Exactly, all the vital stats.
But let's be real for a second. What if, after all this searching, all this hype, we don't find Planet 9? What happens then? Is the whole search just a waste of time?
Not at all. Even if Planet 9 turns out to be a cosmic red herring, the search itself is pushing the boundaries of our knowledge and our technology in really valuable ways.
Oh, so?
Well, we're developing new instruments, new techniques, new ways of understanding the universe.
Right.
And these advancements have ripple effects across all of astronomy.
Interesting. So it's not just about finding this one planet. It's about advancing our understanding of the cosmos as a whole.
Exactly. It's a win-win situation. Either we make this groundbreaking discovery or we significantly advance our scientific understanding in the process.
That's a good way to look at it.
And that's the beauty of science, isn't it? It's all about exploration, pushing the limits of what we know, what we can observe, what we can even imagine.
It really is. So even if we don't find Planet 9, it's not a failure. It's like a stepping stone to something even greater.
Exactly. Who knows what other mysteries we might uncover along the way, what other wonders are waiting to be discovered.
Well, that's a great note to end on. This has been an incredible deep dive into a truly captivating cosmic mystery.
It has.
We've talked about the tantalizing clues, the incredible technology that's being used to search for Planet 9, and the potential implications of finding a new world in our solar system.
Yeah.
And, even though we don't have all the answers yet, the search itself is a testament to our human drive to explore, to understand, to unlock the secrets of the universe.
Couldn't have said it better myself.
And who knows, maybe somewhere out there in the darkness, Planet 9 is patiently waiting to be found, ready to reshape our understanding of our cosmic neighborhood and inspire a whole new generation of explorers.
That would be amazing.
And on that note, we leave you with this final thought. If Planet 9 does exist, what other secrets might our solar system be hiding? What other wonders are out there, just beyond the reach of our current understanding, waiting to be discovered? Until next time, keep looking up and keep exploring.